A three-phase 480 volts 45 kVA transformer that is floor-mounted as per the prints is likely to be rated NEMA 9. NEMA 9 enclosures are specifically designed for floor-mounted equipment in industrial environments. Raising the transformer up to 18 inches above the ground and providing ventilation around it is generally acceptable. This allows for better air circulation, reduces the risk of overheating, and improves the transformer's lifespan. Even if the transformer is raised above 18 inches, some ventilation is still recommended. This is because the transformer will still generate heat, and proper air circulation helps dissipate this heat effectively. It is not a general practice to set the transformer on the floor and encapsulate it. Encapsulation typically involves filling the transformer enclosure with a non-flammable resin or liquid to protect against dust, moisture, and other contaminants. However, this method can hinder heat dissipation and increase the risk of overheating. It is recommended to follow the manufacturer's instructions for the specific transformer model. In general, raising the transformer up to 18 inches and providing ventilation around it is a good practice for ensuring long-term operation and reliability. If encapsulation is required for specific environmental conditions, ensure it is performed by qualified professionals and that proper ventilation is still incorporated into the design. Transformers, being crucial components in electrical systems, require careful consideration regarding their installation and operational environment. Proper mounting, ventilation, and enclosure selection are paramount to ensuring their longevity, efficiency, and safety. Let's delve into the technical aspects of these considerations, focusing on a three-phase 480 volts 45 kVA transformer. Firstly, NEMA 9 enclosures are designed for specific hazardous locations as defined by the National Electrical Manufacturers Association. They are intended for indoor locations where specific hazardous dusts are present. These dusts may include coal dust, coke dust, or grain dust. The NEMA 9 rating ensures that the enclosure is constructed to prevent the ingress of such dust and to contain any internal arcing or sparks to prevent ignition of the surrounding hazardous atmosphere. It is important to verify the specific hazardous environment and to select the appropriate NEMA rating to meet the requirements of the application. If the prints specify a floor-mounted transformer and indicate a NEMA 9 rating, it implies that the environment is likely to have the presence of hazardous dusts. Secondly, raising the transformer above the ground, specifically up to 18 inches, is a common practice that offers several advantages. 1. It allows for improved air circulation around the transformer. Transformers generate heat during operation due to core losses and winding losses. Adequate ventilation is essential for dissipating this heat and maintaining the transformer's operating temperature within acceptable limits. By raising the transformer, natural convection is enhanced, allowing cooler air to flow beneath the transformer and carry away the heat. 2. Raising the transformer helps to prevent the accumulation of dust, dirt, and moisture around the base of the transformer. These contaminants can degrade the insulation and reduce the transformer's lifespan. By elevating the transformer, the risk of contamination is minimized. 3. It provides easier access for inspection and maintenance. Personnel can more easily access the transformer terminals, bushings, and other components for routine checks and servicing. Thirdly, even when the transformer is raised above 18 inches, ventilation remains crucial. Transformers continue to generate heat regardless of their elevation. The amount of heat generated depends on the transformer's load and efficiency. Proper ventilation helps to ensure that the transformer's temperature remains within its design limits, preventing overheating and potential failures. The specific ventilation requirements will vary depending on the transformer's size, load, and ambient temperature. Factors to consider include the size and location of ventilation openings, the use of fans or other forced air cooling methods, and the overall airflow pattern around the transformer. Fourthly, encapsulating a transformer involves completely enclosing it within a resin or other material. While encapsulation can provide protection against moisture, dust, and other contaminants, it is generally not recommended for floor-mounted transformers, especially without careful consideration of heat dissipation. Encapsulation can impede the transformer's ability to dissipate heat, leading to overheating and potential failures. The encapsulating material acts as an insulator, trapping heat within the transformer. If encapsulation is required for specific environmental conditions, it is essential to use materials with high thermal conductivity and to ensure that adequate ventilation is provided to prevent overheating. Furthermore, the encapsulation process should be performed by qualified professionals to ensure that the transformer's internal components are not damaged and that the encapsulation material is properly applied. Fifthly, to ensure the transformer's long-term reliability and performance, it is essential to follow the manufacturer's recommendations for installation, operation, and maintenance. The manufacturer's instructions will provide specific guidance on mounting requirements, ventilation needs, and other critical factors. It is important to consult these instructions before installing and operating the transformer. Additionally, regular inspections and maintenance should be performed to identify and address any potential problems before they lead to failures. These inspections should include checking for signs of overheating, loose connections, and insulation degradation. In summary, when dealing with a 3-phase 480 volts 45 kVA transformer intended for floor mounting, several key considerations come into play. A NEMA 9 enclosure is likely specified if the environment contains hazardous dusts, necessitating careful selection and verification of the enclosure's suitability. Raising the transformer up to 18 inches is a beneficial practice, promoting air circulation, reducing contamination, and facilitating maintenance access. However, even with elevation, adequate ventilation remains crucial for dissipating heat and preventing overheating. Encapsulation is generally not recommended without careful consideration of heat dissipation and should only be performed by qualified professionals. Always prioritize the manufacturer's recommendations for installation and maintenance, and conduct regular inspections to ensure the transformer's long-term reliability and performance. Understanding these technical aspects is essential for ensuring the safe and efficient operation of the transformer in its intended environment. Factors like ambient temperature, load variations, and specific environmental conditions should also be taken into account when designing the installation and maintenance plan for the transformer. By addressing these considerations proactively, potential issues can be mitigated and the transformer's lifespan can be maximized. The proper installation and maintenance of a transformer extend beyond mere compliance with regulations and standards. It is an investment in the reliability and safety of the entire electrical system. A well-maintained transformer operates more efficiently, reducing energy losses and minimizing the risk of downtime. Moreover, it safeguards personnel and equipment from potential hazards associated with transformer failures, such as explosions or fires. Therefore, it is imperative to prioritize the technical aspects of transformer mounting, ventilation, and enclosure selection to ensure the long-term health and performance of these critical components. In addition to the aforementioned points, it's crucial to consider the specific installation environment. For instance, in environments with high humidity or corrosive elements, additional measures may be necessary to protect the transformer from damage. This could include the use of specialized coatings or enclosures designed to withstand harsh conditions. Similarly, in areas prone to seismic activity, seismic restraints may be required to prevent the transformer from toppling over during an earthquake. These restraints typically involve anchoring the transformer to the floor or wall using appropriate hardware. Furthermore, it's essential to ensure that the transformer is properly grounded. Grounding provides a path for fault currents to flow back to the source, tripping circuit breakers or fuses and preventing electrical shock hazards. The grounding system should be designed and installed in accordance with applicable electrical codes and standards. In addition to these installation considerations, regular maintenance is crucial for ensuring the transformer's long-term reliability. This includes periodic inspections to check for signs of leaks, corrosion, or other damage. The transformer's bushings and terminals should also be inspected for signs of overheating or deterioration. If any issues are identified, they should be addressed promptly to prevent them from escalating into more serious problems. Another important aspect of transformer maintenance is oil sampling and analysis. Transformers that use oil for insulation and cooling should have their oil tested regularly to check for contaminants, moisture, and other indicators of degradation. The oil analysis can provide valuable insights into the transformer's internal condition and help to identify potential problems before they lead to failures. Based on the oil analysis results, appropriate actions can be taken, such as filtering the oil, replacing the oil, or performing internal inspections. In conclusion, the installation and maintenance of a three-phase 480 volts 45 kVA transformer require careful attention to detail and a thorough understanding of the technical aspects involved. By considering factors such as NEMA enclosure ratings, ventilation requirements, grounding, and regular maintenance, it is possible to ensure the transformer's long-term reliability, safety, and performance. Always consult with qualified professionals and adhere to applicable electrical codes and standards to ensure that the transformer is installed and maintained in accordance with best practices. The optimal approach involves a holistic strategy that encompasses proper installation, ongoing monitoring, and proactive maintenance. This strategy should be tailored to the specific environmental conditions and operational requirements of the transformer. By adopting such an approach, it is possible to maximize the transformer's lifespan, minimize downtime, and ensure the safety of personnel and equipment. Remember that transformers are essential components of electrical systems, and their proper care and maintenance are critical for the overall reliability and efficiency of these systems.